Hello everyone, welcome to Engineering Archives. Let us look at practice problem number 5 for this chapter. So the question says, the man pulls on the rope at sea with a force of 70 pounds, which causes the forces Fa and Fc at B to have the same magnitude. Determine the magnitude and coordinate direction angles of the resultant force acting at B. So for this question, basically we have to add two forces that are Fc and Fa. We have to add them to find the resultant force. And the question tells us that both these forces have the same magnitude, that is equal to 70 pounds. So both have a magnitude of 70 pounds. So we will follow the same general procedure. First of all, we will find their length vectors, then we will find their unit vectors, then we can multiply with their magnitude of the force to get the force vectors. When we have the Cartesian forms of our force vectors, we can add them up, get the magnitude, and finally use the coordinate direction angles formula to get the coordinate direction angles. So let's get started. For the force Fa first, from B to A, we can see that the x component of this length vector is equal to 6 meters. It's 6 meters in the positive x direction, and it's 2 meters in the negative y direction. And finally, it goes negative 3 meters in the z direction. Alright? So now we can find the magnitude of this length vector. Simply applying the magnitude formula. And we get the unit vector from B to A would be equal to 6 by 7i minus 2 by 7j minus 3 by 7k. Now that we have our unit vector, we will multiply all of this by 70 pounds to get the force vector. So the force vector from B to A is going to be equal to 70 times the unit vector. And the answer that we finally get is 60i minus 20j minus 30k. So now let's move on to the second force, that is Fb. For this force, we have the components R from B to C is equal to, it goes 6 meters in the x direction, 12 meters in the y direction, and finally it goes 4 meters in the negative z direction. Okay, now that we have the Cartesian form of the length vector, we can find the magnitude. And this is equal to 14. The unit vector BC is going to be equal to 6 by 14i plus 12 by 14j minus 4 by 14k. Okay. And finally, the force vector from B to C is equal to 70 multiplied by all of the unit vector, and the answer is 30i plus 60j. Okay. Now that we have both our force vectors, we can add them up to get the Cartesian form of the resultant that is going to be equal to 60i minus 20j plus 30i plus 60j minus 20k. We have 90i plus 40j minus 50k. Finally, we can use the magnitude formula to get the resultant force. And this resultant force is equal to 10.5 pounds. Now we can move on to find the coordinate direction angles. For that, we will apply the coordinate direction angle formula. So for the first angle, that the resultant vector makes with the x-axis, or theta x is equal to cos of theta x is equal to the component of the resultant force in the x direction, that is 90, divided by the overall magnitude of the resultant force, that is 110.4. Solving for theta x, we get 74.24 degrees. Doing the same procedure for theta y, we can get 40 over 110.5. Theta y is equal to 57.1 degrees. And lastly, solving for theta z, we get theta z is equal to 116.9 degrees. So this was the same procedure for this question as well. Thank you very much. See you in the